Today we're going to be simplifying rational expressions. So the essential question is, what should I always check for when I'm simplifying rational expressions? So when you're simplifying a rational expression, you're always going to follow these three steps. First, we are going to take out the greatest common factor if possible. So we're going to factor by taking out the GCF. If we can't take out the GCF, we're just going to factor whichever way we need to. Now, we discussed the 5 different ways that we've learned to factor. We talked about greatest common factor, difference of squares, sum and difference of cubes, factoring just regular trinomials that do not have a number in front of x squared, and then AC method. So those are all the possible ways that you could factor to simplify. And then lastly, you're going to cancel out any common factors. So these are the things that you're going to do to make this work. The first things you should always look for, though, is can anything be factored by greatest common factor? And if not, then how could it be factored? So we're going to start with this expression, x squared minus 2x minus 15 over x squared minus 9. So first we're going to look at the numerator and the denominator separately, and we're going to factor each one. So if I look at the top one is just a regular trinomial. There's no number in front of x squared here. So what I have to do is I have to find numbers that multiply to be negative 15 that add to equal negative 2. So I could do 5 and 3, and the 5 would have to be negative in order to make it add to be negative 2. So what's going to happen is when we factor the numerator, we get x minus 5 times x plus 3. If I were to double distribute this out, I would get x squared minus 2x minus 15, which is what I started with. Okay, so that's the top one. The denominator, what type of problem is that? That one would be a difference of squares because x squared is a perfect square and 9 is a perfect square. So if you remember, to factor our difference of squares, we have to take the square root of both numbers. So in this case, a would equal x if we took the square root, and b would equal 3. And when we factor a difference of squares, we have a plus b times a minus b. So we would take x minus 3 times x plus 3. Okay, and if I were to double distribute that, it would come out to be x squared minus 9. So that's how you can check your answer if you're not sure if you factored correctly. Okay, then at the end, we would cancel out any common factor. So since I'm dividing, anything that's the same on the top and the bottom will cancel out. So my final answer will just be x minus 5 over x minus 3. I can lose the parentheses because there's nothing else with it. So you can lose the parentheses at that point for those. Okay, now if we were taking out the greatest common factor, here's an example where we would do that. So if I look at this expression, if I look at the top and the bottom, they only have 2 parts. They're not a difference of squares. They're not a sum of cubes. They're not a difference of cubes. So the only way I could factor would be to take out the greatest common factor. So on top, the greatest common factor, I could divide both numbers by 20. And I could also take out an x from both parts. So if I take 40x squared divided by 20x, 40 divided by 20 would be 2, and x squared divided by x would be x. And then if I take 20x divided by 20x, I get 1. So if I want to check, I could distribute this and I should get what I started with. Okay, and then I have on the bottom my greatest common factor. I could divide both numbers by 10, and I could also take out an x. So then I get 10x squared divided by 10x would just be 1x, and 30x divided by 10x would just be 3. So this is what I'm left with. Now I need to see if there's anything that I can cancel out or simplify. So if I look at this, 20 over 10 can be simplified. 20 divided by 10 would just be 2, or 2 over 1, but you don't need a 1 on the bottom. The x's would cancel out, and so then I would have 2x plus 1 left on top, and I would have x plus 3 left on bottom. So this would be the final answer. Okay. All right, so we kind of already talked about this, but just to recap, the formula for difference of squares, if you have a number squared minus another number squared, you take the square roots of the number and you get a and b, and then you fill those into this formula. So you have one that's a positive and one that's a negative factor. So, for example, on this example, x plus 4 over x squared minus 16. I want to look to see if there's anything that has the greatest common factor, and there's not. So then I just have to factor what I can. I cannot factor the top because x plus 4 cannot really be simplified. You don't really have to put parentheses around that, but some people like to. For the bottom, this would be a difference of squares because x squared is a perfect square and 16 is a perfect square. So if I were to take the square roots of those, then a would equal the square root of x squared, which is x, and b would equal the square root of 16, which is 4. So then I would have x plus 4 and x minus 4 is what that would factor into. And if I multiplied that back out, I could check and I would get x squared minus 16. So now I'm going to cancel out any common factors. So the top and the bottom cancel out. I don't know why I wrote a plus sign there. So then, since there's nothing left on top, I have to make sure I have something as a placeholder on the numerator. So I'm going to keep a 1 there, and I'm going to keep x minus 4 on the bottom. And you can lose the parentheses because there's nothing else to multiply it with, or you can keep them there if you want to. So this would be the answer. Okay. Factoring a sum and difference of cubes. Now we talked about this the other day. There's formulas for factoring a sum and difference of cubes. You can also remember SOAP to help you remember about the positive and negative signs in the formula. It goes same, opposite, always positive. So for example, if I have a sum of cubes, if I'm adding, then the formula is a plus b times a squared minus 2ab plus b squared. All right, sorry, I had to change something. I noticed that the formula on these was incorrect. The formula should be a plus b times a squared minus ab plus b squared. So the sign is the same here as it was to begin with. This sign is the opposite of that, and this sign is always positive. So same, opposite, always positive. The difference of cubes formula is exactly the same, but the signs are different. So because this one is a difference of cubes, this sign is the same, this sign is the opposite, and this sign is always positive. So that's where the SOAP acronym comes from. So let's take a look at another example. So we have 2x squared plus 6x plus 18. So over x cubed minus 27. So I need to check first, always, to see if there is a greatest common factor that I can factor out. On the top, I could factor out a 2 from everything. So if I divide everything by 2, then I would have left over x squared plus 3x plus 9. Okay, and then I can factor the x cubed minus 27 because that would be a difference of cubes. So to find a and b, I would have to take the cube roots of the numbers. So a would equal x, and b would equal the cube root of 27, which is 3. So now I'm just going to fill those numbers into the formula. So I have a minus b, so x minus 3, times a squared, which would be x squared, plus a times b, which would be x times 3, which would be 3x, and then plus b squared. So 3 would be, 3 squared would be 9. Now, if you look at the top, I could see if I could factor this down further because it's a trinomial, but I'd be looking for factors of 9 that add to be 3. And if I think of the factors of 9, it would be 1 and 9, but those would add to be 10. Or I could do 3 and 3, but those would add to be 6. So this one is actually not factorable, but you'll notice that they're the same on the top and the bottom. So these will actually cancel out. So my final answer will be 2 over x minus 3. So what we did was we factored the numerator by taking out the greatest common factor, and then we factored the denominator as a difference of cubes, and then we just canceled out any common factors that we had and simplified. So make sure you go back to the essential question and write your summary.